Good morning everyone. So we are going to discuss, first of all, thank you very much for participating in yesterday's test paper. So hereby I am going to explain some questions of trigonometry part of yesterday's test paper. So let us begin with the first question. Period of hyperbolic sin x upon 5. Let me introduce you with the concept of period. Period of hyperbolic sin x is 2 pi I. Why do we say this? Period is some small quantity. Period is a small quantity which is added to x, and we get the same result. Result does not change, means we get the same hyperbolic sin x again, even if we add 2 pi I in x. Let us understand why it is so. So hyperbolic sine function is defined as in the powers of e, irrational number e, which is simply e to the power x minus e to the power minus x upon 2. But e to the power 2 pi I is 1, and e to the power minus 2 pi I is also 1. So this will lead to e to the power x minus e to the power minus x upon 2, by which we get hyperbolic sin x again. So 2 pi I is the least quantity, which if added to x we get the same result, hyperbolic sin x again. So 2 pi I is known as the period of the hyperbolic sin x. Here in the question paper, we are asked to find the period of hyperbolic sin x upon 5. So there is a theorem: if period of hyperbolic sin x is 2 pi I, and we are now asked the period of hyperbolic sin x upon 5, so we just multiply this 5 in this 2 pi I. If it would have been the number not 5, there would maybe 6. So we multiply 6 by 2 pi I to get the period of that function. So in the question there is x upon 5 in place of x, so period is just multiplied by 5 and we get 10 pi I. So the option D is correct. And let us move to the next question. First change this into inverse hyperbolic sine. In place of 1 by 2 there will be 2, and recall the formula of inverse hyperbolic sine z, which is log z plus under root z square plus 1, and put the value of z as 2. We will get log 2 plus under root 2 square plus 1 means 5. So option A will be correct. Let us move to the next question. Inverse hyperbolic sec 1 by 2. So change it into inverse hyperbolic cos, and you will get, in place of 1 by 2 we will get 2, and inverse hyperbolic cos z is defined as log z plus under root z square minus 1. In place of z put 2, so you will get log 2 plus under root 2 square minus 1 means root 3. So option C will be correct. Now move on to next question. Here we are asked to find the value of log minus 1. So there are many values of log minus 1. So let us use the general value of logarithm, and we know that we have studied in class that in principal value we add 2n pi I, then we get all the values of log minus 1. So log minus 1, principal value of log minus 1 is pi I, and add 2n pi I in that, and you will get 2n plus 1 pi I. Means odd multiples of pi I. Odd multiples means 1 pi I, minus 1 pi I, 3 pi I, all these are correct. Now move on to the next question. E to the power 2023 pi I. First of all, write this as e to the power 2022 pi I into e to the power pi I, and e to the power 2022 pi I can be written as e to the power 2 pi I to the power 1011 into e to the power pi I. Now we know that e to the power 2 pi I is 1 and e to the power pi I is -1, so 1 to the power 1011. So finally we will get -1. Let us move on to the next question. I to the power, we are asked the value of I to the power I, so we can write this e to the power log I to the power I, and this will be e to the power I log I. Value of log I is I pi by 2, so e to the power minus pi by 2. Option A will be correct. Amplitude of 2 minus 2 plus 2i, this number will be in the third quadrant, -2, -2, and -2, -2. No, it would not be in the third quadrant. It would be in the second quadrant. -2 plus 2i. So it would be on the line y equal to -x. So angle with positive x-axis is pi by 2 plus pi by 4, and 3 means 3 pi by 4. Option C will be correct. Imaginary part of I to the power I. We have already found the value of I to the power I. I to the power I equal to e to the power minus pi by 2. So there is no imaginary part. Means 0 will be the correct answer. So thank you for